Okay, so good morning and welcome. We're going to talk about lesson 2 today, which is bias on graphs. So I'm just going to go through the goals, talking about what are expected goals today. Our goal is to explain using examples how the same graph can be used to justify more than one conclusion. So how can a same graph can have different conclusion, different interpretation. Explain using examples how different graphic representation of the same data set can be used to emphasize a point of view. So biased graphs are sometimes used to deliberately mislead. Okay, mislead. What does misled mean? Direct in the wrong way. Yeah. So biased graphs are sometimes used to deliberately mislead, direct in a wrong way, and sometimes the graph is just prepared incorrectly. It's not done correctly. So some of the ways that graphs are misleading are when, okay, so these are the what to watch out for. Watch out for. Because when you have one of these scenarios, one of these situations, then our graph could be misleading. Our graph could give us false information. Okay? And when we have false information, then we can have a false conclusion, right? It's like when somebody tells you false information, then you take that information thinking it's a truth, but it's really not. So, let me talk about that first. So the first one to watch out for. The vertical scale doesn't start at 0. Okay, stop right there. What's a vertical scale? Vertical. When we talked about this last time when we were graphing, we said the vertical axis, that's the up and down, right? This vertical axis. So the vertical is the up and down axis, and it says it doesn't start at 0. Okay, we're gonna see why that is a misleading graph when it doesn't start at 0. Okay, so a vertical scale, it doesn't start at 0, and this is called, there's a name for that. This is called truncated graph. Okay, so that means a graph that doesn't start at 0, truncated. Okay, so that's a new word for us. We don't use that word very often, but truncated means it's like cut off. It doesn't start at 0. The second one to look out for or watch out for is that the vertical scale is too big or too small, or it skips the numbers. So the vertical scale, so again, talking about the vertical axis again, it's either too big or too small. Too big or too small. Or that they skip some numbers. Okay, we're going to talk about that in a second in more detail. The third one, the graph is not labeled properly. So this is something that is misleading if the graph is not labeled properly. Labeling the x-axis, the horizontal, and the vertical. And then the fourth one, the data is left out. Well, data is left out. So that one is misleading. Okay? So the very first one that we're going to talk about is called truncated. Okay, what does truncated mean again? It means that truncated doesn't start at 0. So it's kind of cut off. So a truncated graph has y-axis that does not start at 0. So truncated y-axis does not start at 0. These graphs can create an impression of a significant change when in reality there is relatively little change. Truncated graphs exaggerates small differences. Okay, so when there's a truncated graph, it really shows you big difference. So let's take a look at the word truncated. Oh, here. So sometimes it's necessary to truncate a graph to save space. So there's room for that, right? There's a reason why we have to do that sometimes, is to save space. But in this case, showing a break on the y-axis allows us to correctly illustrate the graph that would otherwise be truncated. So there are several ways to indicate a break on the y-axis. So this is the break on the y-axis. So I'm going to show you the one without the break first. Oh, sorry, that has a break in the graph. The one that doesn't have a break, it starts at 0 and it goes up. This is no breaks. No break on y-axis or vertical axis. Okay, no break. Now this part here, these are the ways that you can show a break on the y-axis. Okay, can you see here? This is your x-axis, and then there's a little squiggly thing in here that shows you that this part got cut off, and then they brought the graph down. Okay, so this is the break on the y-axis. Another way that you can show a truncated or a break on the y-axis is this thing. It's just chopped off. Okay, so this is a 0. It looks like it started at 0, but then up here it got cut and then continued again. Okay, and then this one here, it looks like it starts at 0 right there, but then when you go up, this part here got cut off and then continued on. And this one, the last one, it looks like it started at 0, but then look at this piece. The graph, the bar graph itself got ripped, and then you see that it just continues on upwards. Okay, so I'll show you what that looks like on a piece of paper. So what's happening is this. I'll show you on a piece of paper. Just gonna hand draw this. Okay, so this is 0, 10, 20, 30, 40. So that one, this one here, it starts at 0, no breaks, okay? No breaks. But I'll show you what happens when there's a break in the graph. So you see that there are some parts missing, right? It's like somebody ripped it off, okay, or somebody cut it off and then just kind of continued on with the graph. Okay, so that's what it means by a break on a graph, right? It looks like it's starting at 0, but really it's not, because it's not continuing on. Okay. That's the first one that we need to look out for, is our truncated graphs. Let's take a look at the example. Okay. Showing how a truncated graph is misleading. So this is kind of shows why having a truncated graph is misleading. Okay, so it says here, Ralph and Camille are both grading graphs of the amount of aluminum recycled in Manitoba. So, amount of aluminum recycled in Manitoba. So, which one do you think is the truncated graph 1 or graph 2? I'll just go graph number 1 here. So we can say graph 1, graph 2. So which one is truncated? Okay, yeah, graph 2 is truncated. And how do you know that?
Because it doesn't start at 0.
Yeah, it doesn't start at 0. Okay, it started at 12. Okay, and then, but then this one is starting at 0. So this one here starts at 0. This is Ralph's graph. This is how many aluminum is recycled in Manitoba. So as you can see, it looks like it's quite steady increase, right? Quite steady increase. And then over here, what's happening, because they don't start at 0 and you just focus on from 12 to 24, what does that look like to us? What does it? Yeah, it's very steep, right? It looks like for us there's a drastic change. It exaggerated the amount of recycled in Manitoba, right? It looks like it's a lot more, right? Because it's a steeper line compared to this line here. Okay? So notice that Ralph started at 0 and his scale goes up by 5. What does that mean, scale? Okay, so that they have to have an equal spacing and equal increments. So what are we going up by? We're going up by 5 each time. Okay, and it starts at 0. Whereas this one, what does it starts at 12, and what does it go up by? 4. You go up by 4 each time. Okay? So, vertical axis at 12, starting at 12, and goes up by 4. And it makes it look like it's dramatically increased, and the growth is a lot more. It kind of has an exaggerated trend and a graph. Okay, so far so good. Take a look at example number 1. Analyzing a truncated graph. Okay, so during the annual Winnipeg Job Symposium, Thomas visits booth for companies offering plumbing jobs. A large company that hires plumbers handed out brochures showing the salary increases that the plumber can expect over 6 years. So it looks like the plumbers, their salaries are growing, right? Okay, if you take a look at this graph in here, what does that say? On the x-axis, horizontal axis, they're talking about the year, right? Talking about the year. Year 1, year 2, year 3, year 4, year 5, year 6. And then the vertical axis, the vertical talks about annual salary. Annual salary. So how much do they make? Okay. So it says here, Thomas looks at the brochure very quickly. At first, he thinks that the salary in 6 years is about 3 times the salary in year 1. Wow. He's going to earn 3 times more. Do you think that's true? No? Because if you take a look at this, oh, this one here, this is how much I have. And then if I multiply it by 3, is that how much I'm gonna have? Is this true? The answer is no. Okay, well, what in year 1, what is the salary in year 1? Okay, salary in year 1 is what? Yeah, so how do you read this part here? It's about 52,000? Okay. Yeah, we can say 52,500. No. And 50 cents. Right? Because this point in here hovers between 50,000 and 55, so it's the middle of that. 52,500. What about the salary in year 6? What is the salary in year 6?
77 or 72.
Okay. Yeah, probably about 72,000. 500, right? Because if we go from here to here, so from here to here, that's probably the 75,000, right? So it's somewhere under 75,000. So is it true that it's 3 times more? The answer is not. It's not 3 times more, right? Because here is 52. If it's 3 times more, it's gonna give us 157,500. Right? It's gonna be over 150, but it's not.
Times 3?
Times it 3. Yeah. Yeah, it's not 3 times more, right?
Yeah.
Yeah. Salary in year 6 is not 3 times the salary in year 1. It's not. Okay. I'm gonna ask you this. Why do you think they would graph it this way? Why do you think they would graph the way they graphed? Because it's high? Yeah.
And there was a looper.
Yeah, okay. Yeah, so that's a good idea, right? To save some room. Okay, I'm gonna actually write down what you said because there's no room if they start at 0, right? Is that what you said? Erase that part. There is not a lot of room if they start at 0. Right? If they start at 0, then you go to 52,000. That's way too high. Okay. What other reasoning do you think? Why would they draw the graph this way?
Because it's truncated. It doesn't start at 0.
Yeah. So why would they truncate it?
Because it was high in rate.
Say that again.
Because it was high in rate.
High in rate, okay. Yeah. Because the numbers are higher, right? Numbers are higher, right? Per year. And it's also used to exaggerate the trend. It really makes us look at this and say, oh wow, plumbing in 6 years, that's going to be a lot of money. It is still a lot of money. It's just that it tells you that it's going to be way higher than it is, what it actually seems.
Oh, I see what you're doing.
Yeah.
It says it right in 14 where it says 0 and this scale goes up by 5 units. So basically saying that it's going higher
Mm.
and then he exaggerates in the third.
Yeah,
So
exactly.
you're giving those 3 explanations.
Yeah. Later, I'm going to show you how to do this on a graph, when we do graphing. What changes that needs to be made so that it's more accurate? What changes that we need to do to make this more accurate?
Start from 0.
Yeah, we can say start from 0, or we can say, i.e., do not truncate. Do not truncate. Do not,
Exaggerated.
yeah, because it just looks exaggerated. Okay, is that good? So that's the first part, truncated graphs. Oh, can I put it back? Oh, question 8. Oh, question 8, sorry. Okay. Is that okay?
How do you get this?
Oh, how did I get that one? Oh, okay. So the question is, how did I get 52,500? So if you take a look at, I'm gonna zoom this in for a little bit, okay? Right there. Is that clear? Blurry. Okay, there you go, it's better. So when you look at this one here, year one is here. The point is there. So we know that's gonna be a number between 50,000 and 55. 50,000 and 55. So in the middle, that looks like it's halfway point, right? So the middle of that would be, okay, what, I'm gonna ask first, how much did they go up by? 5,000. So 5,000. So they go up by 5,000 each time, right? But then to go from here to there, that's increased by 5,000. But this is only half.
So you're dividing it by 2.
So we're gonna divide that by 2. Half of that increase is 2,500. So 5,000 and a half of 5,000 would be 52,500. Okay? And would you like me to explain this piece? Or are you okay? Are you okay? You're okay. Good. Okay, so now let's take a look at page 16. I'm gonna just zoom out here for a second. Oh, Festival de Voyageur. There was a float about that last weekend. Festival de Voyageur. So the Festival de Voyageurs keeps track of how many people attend the event each year. One of the organizers is concerned that attendance is dropping significantly from year to year. He offers the following graph as evidence of decreased attendance. Oh my gosh, look at this. It's really, really bad, right? Is it really that bad? If I'm looking at this, I would be like, oh, Festival de Voyageurs is in trouble. Right? Has anybody been to Festival de Voyageurs? What is it? That one is at Fort Gibraltar. It's around February, and it's basically focuses on the French Canadian
For trade?
yeah, fur trades and all that stuff. There's like sculpture. It's amazing. It's amazing. So
Went to a folk fest, but not.
oh yeah, that's more like
Never go to a folk fest.
oh, I've never been to that one.
Very, very good.
It's okay if you know that
Artists.
Artists.
Yeah. Folk fest is like all concerts, right? Singing.
But I recommend not to take kids because there's nothing for the kids.
Yeah. That's I heard. That's what I heard. Bring it down a bit? Okay. Okay. So what you can see here is that on the x-axis, horizontal axis, they talk about the year, right? And then on the vertical axis, they talk about what's on this side. How many?
Total of people.
Yeah, number of people, right. We should put that down. Number of people. Alright, so we have x-axis or horizontal axis talking about the date, and then the vertical axis talks about how many there are. The taller they are, the more people there are. Okay, so this, I'm just gonna read question A. So this graph has been truncated. How do you know? Doesn't start at 0. Does not start at 0 on the y-axis or vertical axis. Okay? What effect does the truncation have on the graph? What effect does the truncation have on the graph? It exaggerates the decrease of attendance. It exaggerates the decrease of the attendance. So it looks like it's, wow, that's, by 2017, it seems like no one's going to attend anymore, right? Right? Just by the looks of the graph, looking at the trend, it looks like by 2017, there's no more Festival de Voyageurs. Yes? Which is, it's so sad. Because it's like a lost culture. Okay, letter C. Create an untruncated graph of the same data. Okay. So, what we're gonna do is before we get into the new graph, before we create our new graph, in 2013, how many are in attendance? Okay, maybe the first question that I should ask is, what do they go up by?
200.
Yeah, they go up by 200 each time, right? Do you see that? Does everybody see that? Because it's 34,000 and then 34,200, 34,000. So it keeps going up by 200 each time. So what would this be approximately? So it's halfway.
That'd be like 35,400.
30, because they go up by 200. So instead of going up the full 200, you're gonna just go up half of the 200, which is 100. So it's gonna be 35,900. Okay? Is that good? 35,900. Now what about this one in 2014? How many is that?
34,775.
34. Okay, 34,800 and maybe 75, you said?
Yeah,
Okay.
because it's not right at the line.
It's not right on the line, right? It's not. Yeah. Okay. How many are in 2015? 34,600. Okay, good. And how many are in 2016? 34,100. Okay. So let's take those values, and then we're gonna recreate it. Recreate it. Is that good? Can I move it up? Oh, okay. Sorry. Okay. Is that okay to move it up now? A bit? A bit?
Sean says in 2005 is 34,599.
2015, you mean?
Yeah.
Oh, 34,005. Oh, yeah. I see. Quite, maybe one person didn't come. Or, okay, let's move on. Okay, so the first one, we have to make this a really good graph. Okay, what goes on the x-axis? Years. We're gonna put years, because we need to have a title. What's on the y-axis? Number of people attending. Okay, so what does it say in 2013? So this one here, it's already kind of set up, starting at 0, okay, and then it's going up by 500 each time. So 2013, it's 35,900. 35,900. So it's very, very close to just gonna, right? So if this is 35,500 and then this is 4,000. Yeah, so 35,900 up there. Okay, it's getting close to 4,000 attendees. What about in 2014? It says 34,875. 34,875. So it would be slightly below. If this is 35,000, 30 would be somewhere there. So there was a decrease. There was a decrease, but it's not, that doesn't look like it's a big decrease, right? What about in 2014? 2014 would be 34,600. Okay, so this is 30,000, 34,000 would be 30,000, 31, 32, 33, 34. We should be pretty high still. And then 2016, it's 34,100. It's going to be challenging to see the differences between those.
Just a little smudge.
Yeah, exactly. So it looks like it's not in big trouble after all. Looks like it's not in big trouble after all. Okay. I really have to show you how to do this on Excel program. It's gonna be fantastic. Fantastic. Okay. Let's go to the next one. Okay, why is this misleading? Food collected. Why is this misleading? The first one. So actually it's called pictograph. How many bananas were collected? 4. How many apples collected?
4.
How many cherries collected? 4. But just by looking at the graph and the way it's represented, which one do you think has the most fruit collected? Yeah, just by looking at this one here, it looks like the bananas has the most, right? Because it takes off that one, that many space. But really, in reality, they're all the same, right? So if we make the pictures all the same size, they're all 4, they're all equal. So which fruit was the most popular? Collected the most? Which fruit? They're all the same, right? They are all equal, right? There's no, but when you look at graph number 1, it looks like the banana is the most. Explain how the first picture graph is misleading. So
Less space
the banana
or more space?
has more space, or bigger, oh, more space used, or bigger picture used. Yeah, they used a bigger picture, so it looks like bananas is the most collected from the basket. Okay, so that's pretty much it. How do you like that one? So we talked about bias. We have to look at something about the graph, how the graphs are made. we have to look at, are the graph truncated? Is the graph truncated? Does it start with 0 or not start with 0? Is there any information missing, labeling missing, or any picture that exaggerates things more than the other? Okay, so there are some questions for you to work on assignment number 2. Okay, so please work on assignment number 2 tonight. And then tomorrow, what we're gonna do is we're gonna actually create a graph. And I will have to use I'm gonna use an Excel program with you tomorrow. Okay, so we're gonna do this using Excel program. So when you get here tomorrow, I'm gonna ask you, and there should be probably enough. 1, 2, 3, 4, 8. Okay. If we can't have one thing for each person, and we can have probably 2 computers per person, so somebody can come in and log in. If I could find a different, and then we have that one too, we can use that one as well. Okay, so yeah, so if you come tomorrow,